In this video, we're going to be making the program counter of our SAP2 computer be able to communicate with the bus using the 74245 octal bus transceivers. So let's get into it. Now, what an octal bus transceiver is, it's basically if it has an enabled signal. If that signal is enabled, then the inputs will go on to the outputs, but if it is disabled, it's disconnected from the outputs. That's what it's called tri-state logic. That's what the 74245 chip is, and say it's an 8-bit transceiver, and since our program counter is 16 bits, it's a 16-bit binary counter, so we would need two of them logically. And so you're going to place your 74245s on the breadboard, and we're going to connect pin 10 and pin 10 to ground and pin 20 to 5 volts for VCC and power and ground. And then you're going to connect pin 1, which is the direction pin. You're going to connect that to ground. What that does is, if it's since it's ground right now, the inputs are this side and the outputs are this side, so this side would be connected to the bus. So only if we enable it, then the bus will have whatever value is here. But if it was set to 5 volts or VCC, this would be the input, this would be the output. So these 8 pins are the input, these 8 pins are the output. But since it's set to ground, these 8 pins are the input and these are the output. Let me show you how that works. So basically, if I take an LED and attach it to the output of the 74245 bus transceiver, since we're not actually enabling it to output, the LED is disconnected. It's not a 0, it's just disconnected. And if I were to enable it, you can see this matches up with this, and if I add another one, this matches up with this. So the enable signal is pin 19 on both of them, so you're going to connect those together. That's what I did here. Pin 19 is connected together, and that is your output enable signal. Okay, then the top, so the pins 11 through pin 18 are the 8 input bits. So you're going to connect these 8 inputs, these 8 outputs to these 8 inputs, and you're going to connect this one to here and this one to this chip. So that, usually you read binary as right to left, but in these chips it's actually the reverse, it's left to right. So you can just connect this is the least significant bit, this is the most significant bit. So you can connect the least significant bit to here, and so basically just that. We just reversed the entire number basically. And then you're going to do that for both of the chips. This byte goes to this chip and this chip gets this byte. And the input, however, since this side is going to be connected to the bus because of this direction pin, this is going to be connected to the bus, which means that if we want to load from the bus, these are the pins we want to load from, since these are gonna get to the bus, and whatever is on the bus will be on these pins. So if we want to load something from the bus, we would connect these 8 pins here, which are pin 2 through pin 9. We connect those to here. So the least significant bit, which would be here, goes to the least significant bit, which is on this side of the chip. And you do that for all 8 bits. These two are 8 bits. And basically, since we take the lower byte of the bus, and that's where we load from, so we can either load that into the low byte of the program counter or high byte of the program counter. So you want to connect the low byte of the bus to both of the inputs. So we connected this byte over to these two chips, and that same byte is going to be connected to these two chips. So that's what this is, these wires, these gray wires. Byte is going to be here and here. So what that does is, when these are connected to the lower 8 bits of the bus, and this is going to be the higher 8 bits, if we want to output the contents of the program counter, I can show you this chip here with this LED. So this LED is on right now. This is 1, 2, 3, 4. So the 4th pin here, yeah, this is on. And if I take another LED, the first pin should also be on. Yeah, since we have enabled it, and if I disable it, they're both off. So that's that. We can load any byte from the lower 8 bits of the bus into the low byte or the high byte of the program counter. In the next video, we'll be making the A register of our computer. We're going to be making the A register, and after that we're going to make the temp register B and C, since the SAP2 has 4 general purpose registers. And after that will be the output register or output display register, and then the MAR. Okay, bye.